My name is Victor. I'm a design engineer by profession. Today I'm talking about hardware engineering. I'm talking about securing the future hardware engineering for resilient IoT systems. Firstly, I would like to introduce what IoT is for those of us that don't know what IoT is. So IoT refers to a network of physical devices embedded with sensors, software connectivity that enable them to collect and exchange data. So basically what these devices do is they collect data from a sensor and they exchange data over the internet. So some of the key characteristics of these systems is, one is connectivity. So they connect via things like Bluetooth, Wi-Fi, or cellular network like 4G, 5G network. Then another characteristic is data collection. So, for example, in the healthcare sector, maybe a patient's heart rate is being, the patient's heart rate can be collected, the data of the patient's heart rate can be collected via the sensors, maybe like a thermostat. Then another characteristic is automation. So they interact without human intervention. They interact automatically. So these systems, they are applied in different industries, like the healthcare, which I mentioned earlier, the transportation system, smart grid network, and different. Even in our homes, we use them in our homes to control the temperature of our homes. And so as you can see, that's just like a brief illustration of how it works. So it collects data from the sensors. It connects via your Bluetooth, your Wi-Fi. Then the data is transmitted and processed, and it makes conclusion based on data analytics and sends it to the user interface. This is a live example that you collect data from the thermostat and the temperature data, and you transmit it via your Wi-Fi. Then the data is seen on your phone or your computer. So why is IoT security important? Why do we need to protect these devices or these systems? So there's an anticipated growth of these systems to go to about 75 billion users by the end of 2025. So the key reasons why we need to protect the systems, one, they hold sensitive data. Based on the fact that they are transmitted via things like the Wi-Fi, the Bluetooth, we need to secure them. For example, a patient's record, or maybe like in the banking sector where there are financial records, or another example, like the one I just said just now, the healthcare sector. So we need to protect this data, because if they are not protected, it can actually put lives at risk. Just imagine you lose all the money in your account. You're not going to be mentally okay. You understand? So another reason why we also need to protect them is because these systems, they are used to control devices. For example, with the IoT, you can control your car door, like Tesla. You can control processes in like a factory where there are robots. You can control them from a distance. So it's very important to protect them. Now we've talked about why we need to secure these IoT systems. Let's briefly talk about the vulnerabilities. So these systems, they can be physically attacked. For example, like an IoT embedded camera, a microchip can be placed in this camera and it feeds back sensitive information to the hackers have, so where is this? So another thing as regards the physical attack is the side channel attack. Does anybody know about the side channel attack? So what this does is so this kind of attack is when someone physically doesn't need to affect like the software. So what it does is they observe physical signals like power consumption, your electromagnetic emissions, and the timing of how long it takes to process something. For example, like your ATM card or the transaction card. Another vulnerability is the firmware. So for those of us that don't know what firmware is, so firmware is like the low-level software that runs directly on the hardware, like microcontrollers in IoT. So if attackers can modify the firmware, they can change how a device works and they can control the system. So some of the ways which you can do this is like uploading malicious firmware or inserting an extra code to spy or disable or control a device from a remote location. Now, what are the roles of hardware engineering? So the first one I'd like to talk about is this trusted platform model. So this trusted platform model, what it does is like a small security chip that is built into a computer motherboard. So what it does is it stores sensitive information like your passwords, encryption keys, user certificates. It stores them and keeps them safe. Like the Microsoft Surface and Lenovo ThinkPad, they come with these TPM chips. Also, the BitLockers, it uses TPM to lock your hard drive, so that if someone could take your hard drive, they won't have access to your personal information. So let me show you. So these are the TPM models are like. So they are found in your system, your motherboard, to protect the system, protect sensitive data. The next one I would like to talk about is the physical unclonable functions. So what this does is it has like your fingerprint, so it cannot be cloned. They are basically they have natural imperfections during their manufacturing process to generate a unique identity for each of them, each of the chips. So no two chips are exactly the same. So this can be found in your ATM cards and maybe your transaction cards. Now, another one is the secure bootloader. So the secure bootloader is the very first piece of code that runs on your device when you boot your device. So what it does is it checks if the software that is about to run is safe and has not been changed by an hacker. So it verifies the integrity of the operating system, if it's Windows or if it's iOS, and also allows only signed and verified code to run. This one, I guess many of us will be familiar with it. That's the hardware root of trust method. So what it does is this is like a secure foundation that is built into a device. It acts like the first part of the hardware. It checks and verifies everything. So it ensures that the firmware and software are authenticated and allows only verified devices to operate within a network. So this is also, it's found in, it's used in the Amazon Web Services with special natural security chip. I've shown you this before. So now that we've talked about, the IoT, how hardware can play a role in securing our IoT devices. Now let's talk about building resilient architectures. So the first level. So when we talk about building resilient architectures, architecture is like a structure. So we need to build it at different phases, from the hardware to the firmware to the cloud and network. So let's talk about the hardware. So this is the device, the physical device itself. It's the first and the lowest layer of the defense. So we need to protect the physical device itself. So the ways we can do this is, maybe like using the TPM model, which I showed you earlier, that's embedded in, that's placed in computer motherboards to secure sensitive devices. So we could use that, or we could also use the temper detection. That's by imbuing sensors into our devices, so that if someone tries to tamper with it, we could know an alarm. We could get an alarm signal concerning that. For the firmware, we could use code signing, so that the firmware is digitally signed by the manufacturer. Devices will only run when the firmware signature is valid or verified. We also use the update verification when updates are pushed to a device, and it checks that the update is authentic and untampered before installing it. Now, what are the emerging technologies? We have AI-driven nutrition. So one thing that's growing these days, that's trending these days, is AI, the use of machine learning for anomaly detection, whereby, so let me give an illustration. So like in the banking sector, we have a bank, we have a data of a person. Maybe since when you open the account, maybe you open the account like 6 months ago. Since you open the account, the transaction he has done has been between £1 to about £500. And all of a sudden, when he's seen it, is a transaction of about £10,000. So that's, it's an anomaly. It's an outlier. It's not something that, so that kind of transaction can be spotted as a cyber attack. So this AI-driven nutrition is actually something that's emerging these days. Then the blockchain, we have the blockchain. So the blockchain is used for, it's not just for cryptocurrency, it's also used for identity management. Then things like post-quantum cryptography integration is also emerging. So what are the future outlooks? I've talked about the AI threat detection. Then zero trust architecture. What this does is it allows only. What it does is that it makes every device within a network to be verified, both within the network and outside the network. So it's kind of like the fact that a device is inside a network and it's allowed within the network. It doesn't just trust it. It makes sure that every device that is both within the network and outside the network is trusted, has to be verified before it operates within the system. So that's what this zero trust architecture is all about. Then, securing by design. So this is like the first approach, that embedding security into your design from the beginning from your beginning stage of the design up to deployment stage. Then blockchain, I've talked about the blockchain. The blockchain is all about identity management. So it's not just for cryptocurrency, it can also be used for your hardware security. So what are the practical takeaways for us as engineers and security professionals? The first one is we need to prioritize security at the design phase. Not both, that's a design phase of hardware deployment. Also, we need to implement the layered security that's protecting device across different layers, from the hardware to the firmware to your network. Also, we need to use secure-based models like the TPMs, which I mentioned earlier, and the hardware root of trust methods, such that only devices that are authenticated can operate within the system. Then, we should also try to follow evolving standards like the National Institute for Standards and Technology and the NISA and ISO recommendations to ensure compliance and resilience. Then we should also integrate secure update mechanisms so that our firmware should always be secured while they are regularly updated. Then lastly, we should try and always conduct regular risk assessments, identify vulnerabilities, and adapt to security measures that as threat evolves. Thank you. That's